Right. So go to page 25. Go to the coin toss scenario there. Sometimes the province will ask you to use a visual representation or something like that, a tree diagram. You should be able to do it. This one is a pretty extreme case. Okay, guys? Lots of options here. If you have this filled in and you don't have any more room, I'm going to tell you to find a blank page. Maybe, I think page 30, bottom of page 30. Like you go to page 30, you split that in half. Use the bottom half of page 30 if this is filled in for you already. Okay? Because I want you to have at least one example with a tree diagram. It says, Larissa tosses 4 coins. Determine the probability of at least one. Does that ring a bell, the at least one? Remember I asked you to do total minus? At least one coin will land on tails. I was able to fit the tree diagram on there, so I think you should be too. Okay? So I start way on the left here. I'm going to go heads or tails. You can't do an outcome table with this one because there's more than 2 events. Then you've got heads or tails again. Page 30. Just tell yourself you're going to page 30 for this. That's my second event, right? So how many outcomes would I have if I stopped here? 1, 2, 3, 4, right? 2 coins, 4 outcomes. Keep going. Heads or tails? Heads or tails? That's my third coin. How many outcomes now? 2, 4, 6, 8. And if you think about it, 2 options times 2 options times 2 options, right? 2 times 2 times 2 is 8. So that's what we would expect, but this is a visual. You can see it, right? One more toss. Let's see if we can make this happen. So every single one of these should have. You're not going to get anything crazier than this. Right? This would be as much as I would ask you to do. But to be honest, you could probably solve most of these without a tree diagram. Now let's write out all the outcomes. This first one, if we go up the top here, is all heads. Heads, 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 heads. Then the second one would be 3 heads, 1 tail. This one would be heads, heads, tail, heads. The next one would be heads, heads, tails, tails. The next one is heads, tails, heads, heads. Heads, tails, heads, tails. Keep going. Heads, tails, tails, heads. Then it's heads, tails, tails, tails. So you basically just, if you have a hard time going to the right, start just from here, go towards the beginning like that. That also helps you, right? Next we have, by the way, do you see this divide here? Right, if you go way to the beginning, that's kind of like half of the outcomes, and there'll be another half here. So now we have tails, heads, heads, heads. Tails, heads, heads, heads. Sorry. Tails, heads, heads, tail. Yikes, it's going to be a little tight here. Tails, heads, heads, heads. Hold on. Tail, heads, tail, heads. There we go. You should not have any repeats here. Then it's tails, heads, tails, tails. Tails, tails, heads, heads. Tails, tails, heads, tails. Then it's tails, 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 heads, and all tails. Question. Well, copy this down first. Make sure you have this down. If I asked you now, can you see how many options will have at least one coin landing on tails? Look at this. All of these have at least one tail on them. Which one does not have any tails? This one right here. So this one has no tails. So what do you think it's easier, adding up all the ones that have at least one tail, or is it easier to just say, how many options do you have in total? So your NU, if you don't have this, okay, imagine this diagram is not available. NU would be what? 2 times 2 times 2 times 2, right? 2 to the 4, which is 16. You can't see that. Hold on. 16 options, correct? I hope that at least you would be able to get that. So my probability would be out of 16 for sure. And at the top, you do whatever you feel like doing. You want to add up 15 here? Sure. 15, but there's one that has no tail. So I will go 16 minus 1. So that's 15 over 16. That's your probability. So I will just write it out here. Indirect. Reasoning. I go total minus no tails. And I will highlight the no tails part. No tails. How many are there? Just one option there. And I take that away. How many of them have at least one head? At least one head. If I asked you that, I flip it. You just take away all the tails from the total. You still have 15 out of 16. Okay? Hold on, one more thing. Let's do this on the side here. The probability of all heads. Would you be able to do it without this tree diagram? It's out of 16, right? How many ways can they all land on heads? How many ways is there for that to happen? Based on my tree diagram, there's only one, right? So wouldn't it stand to reason that probability of this not happening is 15 to 16? You see that? So tossing coins is a very classic one. Okay. Another one is a like a family having boys and girls. That's another one. They're trying to move away from that, but that's also like anything that has two options, right? That's usually where you go down to this kind of scenario. Okay. All right. What was your question? Question 9. Question 9. Let's go to page 24. Oh, the password one? I don't like that one. Okay, I'll take this